Now that we've created this contingency table, we can proceed to the calculation of the chi-square statistic. The chi-square statistic is based on the implicit null hypothesis that, in this case, whether someone arrives for an emergency or other is independent of whether they arrive during the day or during the night. And we will test that implicit null hypothesis against the alternative that they are not independent by using the chi-square statistic. To begin, I'm going to delete these two rows and move the data to row 1, and then I'm going to edit and clear formats, and finally I'm going to put this as observed to make it match figure 8.5. This is the observed data. In order to calculate a chi-square, the formula in 8.1 on page 258 says that we need the observed data and the expected data. In order to get the expected data, I'm going to copy the observed data and paste it here and change this to expected, and then finally I'm going to calculate the expected values in the internal cells. The expected values are those values in these 4 cells that we would expect on the basis of this distribution in the marginals. What that would mean is that we would expect to have 30% of 60 in this cell and 70% of 60 in this cell, and so on. The easiest way to arrive at the expected values is to say that this first expected value will be equal to cell B5, which is the marginal total for the arrivals during the day, times cell D3, the marginal total for arrivals for emergencies, divided by all cases. Now, in order to copy this to the other 3 cells, I'm going to fix the D5 with an F4, $D, $5. Then clicking in D3, I'm going to fix that with $3 because I always want to be taking that multiplier from column D. And finally, I'll fix the B5 with a B $5 because I always want to be taking that multiplier from row 5. When I hit enter, I get the first expected value, which is 18. 18 is 30% of 60. Now I will copy this to the other 3 cells, and I have the expected values. Now we need a place to calculate the chi-square, so again I will copy the observed values and paste them here, and I will title this chi-square. Now, according to the formula in 8.1, the chi-square statistic is the sum of the quantity observed minus expected squared divided by expected. So here I will say that this is equal to the observed minus the expected squared divided by the expected. And this is the first value, 1.38, that will become part of the final chi-square. Now I can drag this to the right and drag this down, and there was no need to fix anything because the actual formula moved appropriately as I did that. Now, in order to find the actual chi-square value, which I will put here, I will simply sum the internal values here. So this is equal to the sum of these values. And the chi-square turns out to be 4.96. Now, what is the probability of that chi-square? I will find that with equal CHI DIST left paren. Click on the chi-square value, which is given as x, then a comma, then degrees of freedom. In a 2x2 table, there is 1 degree of freedom. In any contingency table, there is actually rows minus 1 times column minus 1 degrees of freedom. So I'll put in the 1 degree of freedom, and I see that the probability of this value is 0.0259. In general, in this course, if the probability of a statistic is less than 0.05, we will assume that it did not occur by chance. Consequently, we conclude from this chi-square value and this probability that whether a person arrives for an emergency or other is not independent of whether they arrive during the day or night. Finally, let me just put here the critical value of the chi-square, which is found with equal CHI INV, which means chi-square inverse. And for that, we take the probability 0.05 at which we want to assess the chi-square value and degrees of freedom. And we find that the critical value is 3.8. This means that if we had found any value for the chi-square greater than 3.841459, we would have concluded that reason for arrival is not independent of arrival time.